Welcome to WebEx. You will now be placed into the conference.
Hey folks, can you hear me? Hey, all right, I'm back. It's good to be back. Hello everyone, thanks for joining today's webinar on RESTful API Design. This is content that we've been working on for about 6 months now. We've gotten some great feedback with folks who we've shared it with all over the world. API engineers, API product managers, project managers, and we're really looking forward to sharing it with you today. Okay, so let's get rolling. A couple things. The first is please check out our Google group. We'll be having any questions you have. You can either post them here in the chat window or over on the Google group. We also suggest you join the Google group. It's just a general area where folks discuss best practices around APIs, and you can see the URL there, or you can just Google for API Craft on Google Groups. Secondly, all of these webinars that we've done and continue to do are up on YouTube. We have a channel there, youtube.com/apogee. If you just click on that big bright yellow subscribe button on top, you can stay tuned as we post these videos. All right, so let's get started. The first sort of existential question we have to ask when we talk about something as tricky or possibly sensitive as RESTful API design is, do we want to be a Rastafarian or a pragmatist? So your first question might be, what's a Rastafarian? I found this old blog from about 5 years ago where the guy, you can read this definition really quickly. The key words there are zealous, extremely meticulous, and be careful. There are a bunch of folks out there who are extreme Rastafarians, and that can just lead to religious wars and like zealotry and stuff. And we're going to try to avoid that. Instead, we want to focus on pragmatism. And in order to do that, we need to keep in mind what the purpose of an API is. This is the value chain that we often talk about at Apogee. The idea is, if an application developer is going to build an app, there's a bunch of stuff that the application developer needs to think about. And our whole purpose for providing an API is that the application developer can take that API and do something really creative with it, which is not an easy thing to do. So it's our job to make the application developer as successful as possible with the API. So the way that we talk about it is, the whole reason for doing an API is to benefit the application developers. And what that means is, if we're choosing between idealistic for the sake of REST purity or we're being pragmatic, it's really important for us to be pragmatic. And to do that in the spirit of every decision that we have to make, as we'll see in these slides that are about to follow, we're going to do it in the spirit of what is of optimal benefit for the application developer. So that's the starting point. And what that means is, to do pragmatic RESTful APIs, we're really talking about a design problem. And there's a subtle point here. I spend a lot of time all over the world talking with folks who are working on API strategies, and there's a lot of folks that have to be part of an API team. Application developers, product managers, business folks, marketing folks. And the key element, in my opinion, is to get the design right. And a lot of times, engineers will often be responsible for the design. And that's perfectly okay as long as the person or the people who are in charge of it have a certain design touch or a design aesthetic about how they approach things. And that's really what we want to talk about in the rest of this presentation here. So let's take a couple of looks at some examples of bad design. This was one I just had someone sent it to me the other day, which I absolutely love. This is a picture from a men's room. I think it was in a bar somewhere, and you can kind of connect the dots here. There's a little tiny bit of documentation above what looks like a urinal that says this is a mop sink, and you have to think that that's probably not going to be enough to communicate the point of the design at the moment of criticality. This is an important design principle, actually. I should say this is an example of an important design principle called affordance. The idea of affordance is the physical design or the virtual design of the thing itself will communicate how it's supposed to be used, much more than any documentation will. This next picture is a real classic one. There are doors all over, business districts all over the world that have this problem where the design of the handle itself is telling you to pull on it, yet the documentation is telling you to push on it. And of course, most people pull on the door before they realize that they were supposed to push on it. And that's just how powerful the design affordance is. And that's really what we want to do with API design. We think that if an API is designed really well, then the documentation becomes like a secondary or even a tertiary consideration. So let's take a look at this. So when a lot of folks talk about design, they think of really, big, beautiful, artistic undertakings, when in reality, good design, in my opinion, is a lot more utilitarian. This is actually a photo from the early 1900s of the first mile of concrete ever paved anywhere on Earth. And the interesting thing about this is you'll notice there are no lines anywhere on this road. And you can kind of see, if you look kind of midway up the picture on our right-hand side, there's a couple cars who are not, one's kind of taking up what should be 2 lanes and it's causing traffic. So, there were many traffic accidents that happened when the world viewed roads in this way. And then one day, a guy who was actually a road commissioner was driving behind a milk truck, and the milk truck was spilling white milk along the road, and that was an inspiration for him to create this, the idea of doing white lines down the middle of the road. And what's interesting about this is just yesterday, a Dutch design outfit just created an award called Design for Function. And this is the inaugural award, and they actually gave it to Edward N. Hines. He's the man who invented this idea of putting stripes down the middle of the road. And I think it's just a beautiful expression of what it means to be utilitarian. There's nothing really especially artistic about these lines, but there are very few roads you go on anywhere in the world now that don't take it for granted that there will be stripes or some kind of indication where the lanes are in the road. Really simple insight. So with that as inspiration, we look at APIs. So at Apigee, we've built a bunch of what we call API councils, which are essentially clients for APIs. And in doing this, we've created a lot of wisdom and experience about what an API looks like. The good news is we have a lot of information to share. The bad news is, especially for application developers, is anytime you move across one of these APIs to another API in the process of building your app, there's going to be a lot of issues in terms of things not being consistent, even though semantically something might be exactly the same on the Delicious API as it is on the Koala API, they'll be expressed very differently. So we hope that through these design webinars, we can help to get folks on the same page. So our exercise for today is to look at a very benign object or resource and model it as an API. We're going to start with looking at puppies. So if some of you have tuned into the first edition, some of the stuff at the beginning is going to be identical to what you've seen before, but we'll very quickly be adding new content that you haven't seen before. So here is the thing that we're going to model. This is a cute little beagle, and we're going to try to create a RESTful API that interacts with this beagle. So here is a typical starting point that you'll see for a lot of APIs. The idea here is we're going to create essentially a method-driven approach to finding the API. You can almost imagine that there's an application developer somewhere who, as he's building out each part of the app that's going to use the dog API, he's just building in ad hoc the method calls that he wants. What's bad about this is you'll notice that some of these base URLs have verbs in them, some of them don't. Sometimes the verb's at the beginning, sometimes the verb is at the end, and there's not a whole lot here that is teaching the developer what he should do to be thinking about the API. It's a really lost opportunity. So when I created what appears to be a random API, it was actually very difficult to create a bad API when I set out to do it. So I actually looked at this API. The source of it will remain anonymous. This is an API from the financial services industry, and you look at it, and it's really in bad shape. This API does not teach anyone anything about how to think about the overall domain that the API works in. This is bad news. Where it gets worse is you can imagine that the API team responsible for this, sometimes people are going to, I just noticed that chat window. Yes. If some people will be working on this project, some people are going to remove themselves from the project, new people will be hired in, and every time a new person tries to add a method to this API, the chances of them improving it are very small, but the chances of them making it more confusing are very good because there's no consistent pattern here that folks can learn from. Not to mention that just this, the layout of the documentation is really annoying. Like they dedicate 2/3 of the space to this repeating acronym. One is SOAP, which most people understand, but this other one is MVP, which I actually had to look up. It actually stands for name value pairs. So there's very little about this that's obvious. And there's bad news here because it's going to get worse. For any resource that you model, you never look at one object in isolation. Things are always interacting together. In the case of our puppy, the puppy's world is pretty big. There's food, there are squirrels that he will want to chase, there are veterinarians, there's owners, and owners will have leashes. So there's all these other objects. So if you think about the method calls that we need to create to address not only the baseline world of just the dog, but all the other objects that are commingled in this dog's world, things are going to get out of control very quickly. And so we went from bad news to worse news in a hurry. So essentially, we're on a slippery slope where this is going to be a very miserable experience. If anybody has lived in a project like this before, things can get miserable. It's not fun to go to work in the morning when you have to not only write the code that's driving the API, but also the application developers that are consuming the API. So we want to talk about what we can do to fix that. So a couple simple principles. The first is a real obvious, well-stated one, which is keep the simple things simple. And in the world of application development, from my perspective, if something is truly simple, especially in the world of RESTful APIs, that means a developer should be able to copy and paste the URL into the web browser, hit his forehead on the enter key, and something meaningful should happen without a whole lot of thought going into it. So the key litmus test here is we really only need 2 base URLs per resource. So whenever I'm reviewing an API, that's the first thing I look for. I say, okay, how many base URLs are there? As soon as I see 4, 5, 6, 7, 13, or 15 per resource, I know that this is definitely not anywhere near a RESTful API. So what are those two URLs? The first is for a collection. In our case, we'll call it /dogs. The second URL is for a specific element within that collection. So in this case, it would be /dogs/1234 or whatever the primary key or the unique identifier is for that resource. The reason that we can get away with that, only having 2 base URLs, is because we're picking up 4 verbs from HTTP: post, get, put, and delete. Of course, for me, those map back to CRUD, which is create, read, update, and delete. So if we take those 4 verbs and multiply it across those 2 URLs, we start with 8 interesting things that you can do to this API. And there's a great table on Wikipedia that outlines this stuff. I disagree with some of the things that they say because it's a little confusing. And I end up with a chart that looks like this. And I'm just going to walk through each of these 8 cells very quickly, just in the spirit of being complete. So the first cell, doing an HTTP post to the dogs collection, that will create a new dog within the collection. If I do a HTTP get to dogs, I actually get a list of all the dogs resources that are available. If I do a put on dogs, then I'm actually doing an update of some attributes on the dogs. So imagine you take some subset of all the dogs in a collection and change their state from running to sitting. And then finally, if I do a delete on dogs, then I'm deleting all the dogs from that collection. Okay, hopefully that's pretty obvious. Now moving on to the element. If I do a post on dogs / whatever the identifier is, in this case it might be Bo, then I think the official REST way of doing this is to actually create a new dog as if the person were making the request on the collection. But I think that's a bad idea because you're allowing the developer to do things more than one way. That isn't very intuitive, and instead I think that should fail fast and return an error. If I do a get on a specific element, I should get back that specific element. So in this case, I would be showing a dog with an identifier of Bo. If I do a put on Bo, if that resource already exists, then I should do an update. If not, I should send an error. And then finally, if I do a delete on Bo, it should delete that specific resource from the database or whatever the backend storage is. So with just those 2 resources multiplied times the 4 HTTP verbs, we get a nice rich set of capability that we can do. And this is really, from my perspective, this is the key insight to Pragmatic REST. So what do we learn there? Overall, verbs are bad. And by that I mean putting the verb into the base URL is the first step on the slippery slope where it starts to become very confusing. So it's a good idea to keep those verbs away from the base URL. And instead use nouns. Nouns are really good. Now when it comes to actually designing the labels, the first question that I often see asked is, should we use plurals or singulars? The quick answer to this is, you should choose one or the other. If you choose a mixture of plurals and singulars, it's going to be very confusing, and it's going to make it more difficult for developers to do something very important in the way that they work, which is guess the answer. If they know that you're consistently using plurals or you're consistently using singulars, it makes it much easier for the developer to guess what a method call might look like. Okay, so let's take a look in the same spirit what some of the leading APIs are doing. So here's a look at Foursquare, Groupon, and Zappos, looking at what is the key resource for their business. For Foursquare, it's check-ins. For Groupon, it's deals. And for Zappos, it's products. Foursquare and Groupon both choose to use plurals, whereas Zappos chooses to use singular. When I think about this, the first thing that anybody's going to do with a RESTful API is make an HTTP GET on it. And so if you think of that as kind of the baseline, I think it just reads much easier to say get check-ins or get deals or get products than it does to say the singular of those. Plus, by the time if you're looking for just one element, say /check-ins /1234, it's already pretty obvious that you're looking for one element. So my recommendation with this is that plurals are better. So use nouns, pick plurals, and make it consistent all the way across the board. It's just going to be much easier for the developer to guess. This is another thing that I see a lot, and this is where, when I talked at the beginning about having a design touch or a certain design aesthetic about designing something, there's a whole other way of looking at problems like this, like API design, where especially architects are guilty of this, where the idea of achieving pure abstraction is the consummate goal that you could ever want to achieve. But it's not always the case that will be meaningful to the developer. So let's take a look. So in the case of what we're doing now, where we're modeling dogs, here are 4 different levels of abstraction that you could use for labeling your resources. So you could start at a super high level of abstraction and just model all things. In that case, leashes, veterinarians, people, squirrels, dogs, trees, parks, they would all sort of be parameters underneath this idea of things. Or you could take it a step down a level and say, okay, we'll have animals, maybe we'll have animals and peoples and inanimate object. Those will be like the main things. So we're slowly moving down a level. And then finally, like a medium level of abstraction will be dogs, and then a lower level of abstraction might be a specific dog like beagles. So if you Google the API for the Guardian newspaper in the UK. Now the Guardian newspaper has all this really rich content, blogs, videos, news articles, packages of stories all put together to be really compelling. You'll see that the guys who created the API, they modeled everything down and reduced it down to this notion of an item, which it's achieved a really interesting level of abstraction. But if you go back to our fundamental tenet, which is good pragmatic API design is about the developer, when the developer lands at that API documentation, this is our opportunity to paint the picture for him or her about what they can do with the API. So I think it's much more compelling to see the resources listed as blogs and videos and news reports and special items instead of just this boiled down kind of like a soulless notion of an item. So to wrap all that up, what I think is really compelling, it does depend on your scenario. You don't want 4,000 different types of resources. You want to end up with about a dozen or 2 dozen, but you should really try to aim for the concrete. The concrete is better than the abstract because it makes it much more visceral and tangible for the developer to know what he's trying to build. What about associations? So oftentimes resources have a relationship to other resources. So how do we express those in this RESTful world? Well, that would look something like this. So imagine you have dogs belong to owners. So here, if I wanted to get all the dogs belonging to a specific owner, I would say get owners / the identifier of the owner and then / dogs. And this is going to return to me all of the dogs that belong to that specific owner. And then likewise, if I wanted to create a new dog for a specific owner, I could do a post to that same URL. Now, sometimes when I leave folks and I come back to see how they're implementing their API, if they go to levels beneath this, so you can imagine that maybe the owner has a relationship with veterinarians and then the veterinarian has a relationship with dogs. I've seen folks stream these together like 5 or 6 deep. The key insight here is once you have the primary key for one level, you don't need to include the levels above that because you've already got your specific object. So you really shouldn't see too many cases where this URL is deeper than what you see here, which is a resource name, an identifier, and then a resource name again. So hopefully that's pretty clear about what that's about. All right, now what about complex variations? Clearly, many APIs are going to have a lot of intricacy beyond sort of like the base level of just /dogs, right? Dogs have all kinds of different states which can be updated, they can be changed, they can be queried. There will be a bunch of attributes associated with each resource. So how do we handle that? So the key thing here is to sweep the complexity under the rug, so to speak. And in the world of HTTP, that is all about the question mark. So if we look at something like this, let's just say you wanted to do a get on all of the dogs that had red fur that were running in the park. You can imagine more of an RPC style call where you would say, get red dogs running in park. Yeah, that is a Banksy. That is a Banksy. It's a nice piece of graffiti art. Thanks, Steve. So you could imagine a base URL that looks like that. On the other hand, if you do it this way, then we're doing something really important, which we stated at the beginning, which is you're making it simple still for a developer to go back and use that base URL. So the whole reason, just to state this quickly, the whole reason of putting parameters and other complexity behind the question mark is that's all optional. So you can still make the simple things simple while making the complex things possible. What about errors? Now, most of the time, at least when I was a developer, the stuff I always did not like thinking about was all of the exceptions, all of the error handling and the rescues and the trapping and the throwing that I would need to do around errors. That's a bad idea when it comes to software development in general, but it's an especially a bad idea when it comes to API design, and that's for two key reasons. One is all developers learn how to write code through errors. It's so easy to try something out and let the computer tell you whether it was right or wrong that we just do that instinctively. In fact, there's a whole body of best practices around doing this. It's called test-driven development. The idea of test-driven development is you first create a test suite knowing that it's going to fail and create a bunch of errors, and then you slowly iterate to the point where there are no more errors left. That's the first reason. The second reason is when you're working on a web API, everything on the other side of the interface, from the perspective of the application developer, is a black box. He has no visibility into what's going on there. He probably doesn't have the luxury of being able to tap the person on the shoulder who built the API and ask them what was going on here. So the errors are one of the key pieces of visibility into how the developer should use the API. So let's take a look at how to do errors in a pragmatic way with REST. So keep in mind that not only will the developer be accessing the API during the development process, but also when things are going very poorly. So for example, maybe he's built an iPhone app that's out in the wild and all of his users are reporting errors. So he knows that he's got to fix this thing and find a way to patch that app and get it on all those devices. So this can be a very stressful time in the developer's life. So it's important to take this stuff seriously. So let's take a look at how it's done. Here are how three of the top APIs do it: Facebook, Twilio, and Simple Geo. In the case of Facebook, no matter what happens on a Facebook request, you're going to get back the 200 status code, which means everything is okay. Many of the error messages actually push down into the HTTP response, and you see they do one of my biggest pet peeves here. They throw this arbitrary number here where it says #803 with no additional context. So for me, as a developer, I'm like, that's really frustrating. Maybe I can go Google Facebook API 803 and find something meaningful, but it's pretty frustrating, I think, just to get that random code sitting there. Twilio, they do a great job of bucketing their errors into aligning them in a way that matches really interesting HTTP status codes. So from Twilio, you're going to get a nice status code coming back. And then they also do something I think is really, really strong. They took the same idea that Facebook did by providing you this more granular error message, but they also include a URL where as a developer you can go click on it and you'll land at the docs. Then imagine when you land at the docs that there's actually some commentary or some threaded discussion allowed on that page. Then when the first, second, or third developer hits that error, there's going to be discussion about it so that by the time the fourth, fifth, and so on developers land at that error page, there's a good chance that someone will have already figured out what the error code is, and they'll be providing more context through that commentary. Simple Geo does a similar thing. They provide the error code, but then they don't add any additional value really in the payload. So what are we to make of all of these different approaches to handling errors? I break it down like this. You should use the HTTP status codes as much as possible and try to map them as cleanly as possible to the relevant standard-based code. And there's an excellent entry in Wikipedia about all the status codes that are available. Importantly, that code that comes back, it really should be for the business logic for the application to react to. In an if then else statement or a case statement or whatever it is, there should be some ability for the developer to respond to that. And then secondly, the message that actually comes back in the response payload, the error message, that should be as verbose as possible. And the API team should do everything they can to throw in any ideas they have about what might be causing this error. This doesn't happen very often. Usually what you see is these really minimalistic response messages where it's almost like the developers are trying to preserve bandwidth or network capacity. That's the wrong thing to do here, because this is where if the error is happening, there's a really good chance that the developer is going to be seeing that message so that he can fix it in the code and never have to see it again. So be verbose, use a plain language description, and put as many hints in there as possible. And then I highly suggest that folks also do what Twilio did, where you include a link back to that specific error code, which is probably going to be more granular than the HTTP code. What about versioning? So versioning is a really big topic. If there's one thing you can take away from this whole presentation, I'll say it right here. Don't release an API without a version, and make the version mandatory. It's the most important thing that you can do, in my opinion, for the sanity of the application developers and the sanity of the API team. So let's look at this in a little bit of detail. Here are how 3 API providers handle versioning. Twilio does this interesting thing where when I first saw the Twilio one, I didn't really know how to interpret that. I thought maybe they had reversed, this is mainly because I'm an American and we don't represent timestamps this way. I thought maybe they had reversed the identifier of the account and put the account in front of the account's resource label. But actually what this is a timestamp. And how this works is if you're a developer, say you're compiling an iPhone app, at compilation time, you include the timestamp of the app when it was compiled, and you put that in all your HTTP requests. And then when those requests come into Twilio, they're going to do a quick lookup and say, okay, based on this timestamp, then this was the API that was valid when this code was made, and they'll route you to that API. I think that's very clever, but it takes a while to wrap your head around how that's supposed to work, right? Do I use the date and time of when my code was compiled, or the date and time when the API was released? So even though it's really interesting and powerful, I think that's actually more complex than it needs to be. Salesforce.com, they use v20.0, and that version is somewhere sort of in the middle of the URL. There are 2 things that I don't like about this. One is an API should be a very slowly changing thing. It's an interface. The logic behind the interface can change as rapidly as you'd like, but that interface should change very slowly. So if you put .0 or .1 or .1.2 behind that version number, it creates this implication that the API is going to be versioning probably more quickly than it should. So I actually don't like using the .0 notation, but I do like using the V. And by the way, if you're on version 20 of your API, you should probably be in business for about 40 years with that API. The API just shouldn't change that quickly. And then here's how Facebook does it. They actually make it an optional param. If you do a Google search, actually I haven't done this in a minute, it's been a little while, but if you do, back when I did the Google search on this, if you do Facebook API version, all of the top responses that are going to come back are going to be these discussion threads where people have built apps and they broke, and they're trying to figure out what the solution is. And the reason is because Facebook didn't make the version mandatory. So as soon as they forced their API up to the next version, all of these apps that didn't include the version number broke. And it was too late. All those apps had to be pulled back and then have the version number stuck in there. So that's the pitfall of having your version number be optional. So what's my overall recommendation? Let's break it down like this. First of all, move the version number as far to the left as you possibly can, because it should be the highest level scope. Use a V, because we're all developers, we're very used to this nomenclature of saying V1, V2. We know that means version. Don't use the dot. Don't use 1.0 or 1.1.1. Just keep it as a really simple ordinal number. And that's, I think, is the most readable. It defines the scope at sort of the most accurate level. So that's my overall recommendation on version. And you'll notice that it's mandatory. Now, there's a whole other school of thought on this, which is much more aligned with pure REST, which is the version number should be in the header, and that allows you to do linking. So like if one API request comes back and it has links to other APIs, then you can your code can be versioned independently across those different APIs. That's a whole deeper level of discussion that I'd love to get into with anybody. So if you hit me back, you want to talk about that. But overall, I think that if you take that approach, it's actually a symptom of not having a good pragmatic API design in other spots. And I'll leave it at that for now, but I think this is the recommendation that folks should go with. Okay, now, if you look at Twitter's API and you make the simplest thing you can do, which is a request to a tweet, the tweet comes back with a lot of information in it. There's the name of the person, the actual text of the tweet, the timestamp, how often it's been retweeted, and then a whole bunch of other metadata. That is often overkill for a typical Twitter application. So you need to give the developer a way to pick and choose just the attributes that he needs in order to make the application happen. And here's how a few leading APIs do that. LinkedIn, Facebook, and Google. Google actually pioneered this idea, and they call it partial response, which has a really good connotation on the one hand, and I'll get to why it's not on the other hand a little later. So LinkedIn does this. So the idea here is if I'm making a request on a person, say at LinkedIn, and all I want is their ID, their first name, their last name, and the industry, I use this sort of emoticon syntax where it looks like a frown face at the beginning, followed by the attributes that I need. When I first read the LinkedIn documentation and I saw this syntax, I really had no idea what I was looking at, and it wasn't even possible to do another search to find out what that meant, because it's very hard to do a Google search on : open parenthesis. You just can't do it. So it was very counterintuitive, and it took me a while to figure out that this was actually their way of doing parcel selection. Facebook and Google both handle it in a very nice way, which I'm a big fan of, which is they put the field, they have an optional parameter called fields, and then after that you can put in the names of the fields that you want to come back, you want to have come back. And you can also call sub-objects into the response. So even though on the one hand it gives you partial response, it can also allow you to pull in additional information from other associated resources. And I'll talk about that again a little later on. So what is the best way to do this? I really think Google's way is the best. It's really simple to read. You just put the optional parameters fields, you string them together and make it comma delimited, and you're on your way to making it very easy for a developer to select just the stuff that the application is going to need at a specific time. And that also helps cut down on bandwidth issues, which is important for mobile apps. Okay, what about pagination? Clearly, if you're talking about resources, it's probably always going to be a bad idea to return every single object out of a database that matches a specific query at once. Instead, you want to make it easy for a developer to paginate across the different items in the database. So let's take a look. Here's how Twitter, Facebook, and LinkedIn handle it with their API. So Facebook uses offset and limit. Twitter uses page and something which they have an acronym for, RPP. I had to look this up. It means records per page. And LinkedIn does something called start and count. So semantically, Facebook and LinkedIn do the same thing. You could just swap the numbers for start and count into offset and limit, and it's still going to work. It's the same idea. Twitter is actually different. They use different math. So for example, if I wanted to get records 50 through 75 in Facebook, I used offset equals 50, limit equals 25. For LinkedIn, I say start equals 50, count equals 25. But for Twitter, I actually say RPP equals 25 and page equals 3. So these are different things. Which of these should you choose, or should you choose something else? My opinion is you should use limit and offset. The leading open source databases use limit and offset. It's a really well understood way of doing this type of pagination, and it's going to be easy for developers to grok it right away. And I actually prefer limit and offset instead of start and count because it's just more common. All right. Now, what about formats? So, first of all, what position should you take on formats? Should you support just one and only one format? Should you support multiple formats? My colleague Marsh, who is one of the product guys at Apogee, he had this really interesting way of saying it, which was you should make it really, you should only push things out in one direction, but you should be able to accept things in as many different formats as are needed. So when it comes to formats, you should just map whatever your developers need, because doing transformations from one format to another is something you can usually automate. So it's a good idea to support more than one format. And here's what that syntax looks like. So let's look at Google Data, Foursquare, and Dig. They each do it slightly differently. So Google makes it an optional param. They use alt equals JSON. Foursquare does .json. And then Dig allows you to specify it two ways. One is this very pure RESTful way where you can put it in the accept header that you want to accept JSON, or you can put it as the type param in the URL. The problem with doing it this way is as soon as you allow somebody to specify it in more than one way, then you have to figure out what to do if there are conflicts, which means you have to document what to do if there are conflicts. So in this way, I think that adds to confusion. So my overall suggestion, having thought about this stuff and looked at it from a few different angles, I think the Foursquare way is really interesting. So if you want to get a JSON format off of the collection or a specific element, it looks like this. I like this because even, just casual users of any operating system are comfortable. They've seen this notion before of .json or .xls or .powerpoint or whatever the file type is. You know that you're going to get back data or files in that certain format. And the other nice thing too is it only takes one additional character, that period, to actually get the point across about what you're trying to do. Now, what about defaults? Two things here. When it comes to the format, this is really deep in the opinion area, but I think JSON is sort of winning. And anybody who's building any kind of web-oriented app, they might build the backend in PHP or Java or Ruby on Rails or Python, but they're going to know some front-end JavaScript, or somebody on their team is going to know some front-end JavaScript to make this happen. So I think the JSON, it ought to be the default format because it's the closest thing we have in software today to being sort of like our universal language. Most projects are going to be touching JSON or JavaScript at some point, and JSON, of course, is JavaScript object notation. It's designed for JavaScript. So I think JSON is a really smart default. Not to mention it's pretty terse. It's not as verbose as XML. And then for pagination, this is a real loose rule of thumb because it really depends on your data size. But we have 10 fingers. 10 is a nice round number. I think if you're going to just have a default pagination, having it limited to 10 with the offset 0 is a pretty good way to start. And that can vary based on your resources might be huge, and you might want to limit it to 1 or 2 or 5, or they might be really tiny, in which case it would just make sense to provide more as the default. But as a rule of thumb, I like 10. Okay, what about attribute names? So what I mean by this is when a response comes back, essentially you're looking at an object with a bunch of attributes, data attributes on it. How should you name them? Here are how some of the leading APIs do it. Here's the API response from Twitter, Bing's Search API, and Foursquare. So we're seeing all of the three top ways of doing code convention here. Twitter uses the underscore separating their words. Bing uses camel case with the with the first letter capitalized, and Foursquare uses camel case with the first letter lowercase. So I've gone back and forth on this a lot, mostly because I'm a Ruby guy, so I like the Twitter way of doing it. That's what I'm used to. But having thought about it for a minute, I don't actually think that's the right way to do it. Instead, I think Foursquare has it right here, and here's why. If you think about how an API response gets back into the code, it looks like this. Again, this JSON is for creating JavaScript objects. If we take this as the default, what happens is you do a parse of the response. Ideally, you send it into a JSON parser, and what comes back, it populates that object. Now, if you chose the Twitter approach or the Microsoft approach, that means your code is going to look like this. And this just looks funny in JavaScript. This is not the JavaScript convention. It'd be perfectly fine if you were, sucking this into Ruby, but JSON was meant for JavaScript. So that goes back to my really important, very opinionated assumption on the other page. And then same thing with the Microsoft approach. This looks like it's the name of another object in the system or a class in the system, and that's not cool. So my suggestion is if you're using JSON as your default, which I think you should, then you should follow through with that and follow JavaScript convention when it comes to naming your attributes. So it would be medial capitalization, also known as camel case, uppercase or lowercase, depending on what the type of object it is. So you would look with something like this, and then that would allow the JavaScript programmer to actually write it in a way that makes sense for JavaScript. Okay. What about non-resourcey type stuff? So this is pretty common depending on what domain you are. I often see this in financial services sector, sometimes in the telco sector, automotive to an extent. There are API calls that you make that just don't fit into resources. When you make the request and you get the response, you really don't get a resource back. And a symptom for when you're using a non-resourcey thing is if, as you're thinking about it, you have verbs like calculate or translate or convert. So maybe you have, you're calculating, somebody's tax withholdings. All you really need to know is how much do they make every year, some other information, and you return back to them how much money they should be withholding. So there really was no resource involved. It was just a simple algorithmic calculation. Or maybe it's a translate. You have some natural language text is coming in one language, you want it to go back in another language. Or maybe you're converting from one currency to another, or one type of unit to another. These things are not really resourceful. They don't feel like you're hitting a database. So what to do about that? It's easy. First of all, every other place in your API where it's not a command like this, you should use nouns. But in the cases where you are truly doing something more algorithmic, use a verb and make it very clear when you document the API, like have it in a separate section, that here are some verby type things which are not really resourceful. So if I were building an API for how to do a conversion, I would do something like this, where I just want to convert from euros to Chinese yen. I would say, here's the amount, here's the from currency, here's the to currency. And I think that's a perfectly acceptable way to get around it being not resourceful. Cool. All right, in a similar vein, what about searching? So search really could be modeled as a resourceful API. So for example, if you wanted to search all the dogs, you should just be able to go /dogs/ whatever, or /dogs ? Whatever, to query just the dogs. But when you're going across resource types, you just want to be able to do a sort of a global search based on some query. It's a little bit different. So when it comes to search, Google was the first and best at this. We might as well just follow their lead. So overall, if you're just doing a global search across resources, I suggest you follow what they do, which is /search. Again, this is clearly not a noun. It's a verb, and you have the Q in there for the query, and you put together whatever your query string is. And then for extra credit, if you want to go beyond that, you can scope it. In this case, maybe you want to just search all of Bob's dogs, where Bob is the identifier of an owner. You could put that in front of the search string, and then it would just be scoped down in that way. And then finally, formatting, both for search and for any other type of, one of these more action-oriented requests, you just drop the format in there at the end. What about counts? This question has come up a lot, and I'm going to throw this out there. Maybe as a community, we can talk more about what is the right way to do counts, because I'm not 100% sold on the thing I'm about to suggest, but I think it's a really interesting place to start. So if you want to get a count of all the dogs, you can imagine this is scoped based on what the requester has access to, or maybe there's some additional parameters. But if you want to get an account on this, you almost could think of count as a reserved word. So what this would mean is you could never have an identifier on a resource where the identifier was count, because that would just give back that specific resource. But other than that, I think this is a pretty interesting way to get a count of the resources that are available in the database. I'd love to hear feedback, especially up on the API Craft Google group, whether or not folks agree with this. I think it's a pretty interesting way to do it. There might be others. I'd love to hear back from you guys. All right. So far we've been talking about everything after sort of the top level domain. So let's talk about the stuff that comes on the other side of the slash, the first slash in the URL. So here's how Facebook, Foursquare, and Twitter handle this. Facebook provides not one but two different APIs. They originally started with api.facebook.com, and then they modified it a bit to make it more oriented around the social graph. So then they threw in graph.facebook.com. Foursquare has just one, api.foursquare.com, and then Twitter has three. There's API search and stream. I understand why both Facebook and Twitter ended up with more than one API. A lot of it has to do with acquisition and the timing, and it's really easy to configure a CNAME entry in your DNS in order to point requests to different clusters. But at the end of the day, if we're really making design decisions about what's in the best interest of the application developer, then we really should follow Foursquare's lead and make our best effort to consolidate all the different API requests under one API subdomain. It's just cleaner. And often if you're providing an API, it's because you want a developer to use all this stuff to build a really cool app. So it's important to present it to him in a way that's easy to use all that stuff for a really cool app. And then they also, Facebook and Foursquare and Twitter, they also have dedicated developer portals, and they do it as developers.facebook.com, same thing with Foursquare, and then Twitter does dev. So what you should do, how should we handle all this stuff? Here's my suggestion. Your API gateway, it ought to be at api.your top level domain. Your developer portal, in keeping spirit with REST, it ought to be developers.your top level domain. And then this is sort of very optional. If you can sense from the request coming in that it's coming from Google Chrome and someone typed in api.foo.com and there's no other information in the API GET request, you can probably safely go ahead and do a redirect over to your developer portal just as a courtesy, so that if you sense what they're trying to do, you can help them land at the right spot. Okay, now that's sort of the baseline stuff. Let's talk about some exceptional things, because there are many clients of web APIs that can't handle all the things that we just talked about. So let's look at how some of these exceptions work. So one very common thing, especially in some versions of Flash, is that if you send an HTTP response that is anything other than an HTTP 200 OK, the Flash container itself is going to intercept that response and put the error code right in front of the user, the end user of the app, and your application developer isn't even going to have a chance to intercept that error code, which is really bad news in terms of the application developer trying to create a compelling app. So there are many cases where app developers are in a pinch if the API doesn't support this in any other way. So how do we handle that? Here's how Twitter does it, and I think they do a brilliant job with it. They have an optional param called suppress response codes. And if that param is set to true, then no matter what you do, the HTTP response is going to be 200. Now notice that this param is a nice honking big verbose response code. So if you look at this URL, there's no way you're going to miss that the response codes are being suppressed. And that's really important because it has huge dramatic effects on how the apps are going to respond to it. They could just have easily said SRC, but they didn't. They spelled it all out, and I think that is exactly the right thing to do here. And then, they also, but what they don't do right is they don't put an error code down into the message. So my overall suggestion to handle this is the following. Use suppress response codes equals true. That's the right thing to do. When you do this, our rules from earlier change. The HTTP code is no longer just for the code, the program. It's now to be ignored. So any client app that's using this approach, they're never going to be checking the HTTP status code because it's always going to be the same. And instead, whatever response code we were going to put into the HTTP status code, we should push that down now into the response. So here you would say the response code is 401, and then you would also include your additional error codes in that message. I hope that's clear for folks to understand. Now, what about the case when your client supports only a limited HTTP methods? Like a common one is they only support get and post, but not put and delete. I really like to see folks, even though that's the case, it'd be nice if you still maintain some of the integrity of those 4 HTTP methods. So my suggestion is to do this. Anybody that's in the Ruby on Rails community know that this is just what we do with Rails. You put the method as an optional param up there in the URL, and then the HTTP verb itself is always a get, but you are able to, the developer is able to express all of these rich HTTP verbs and still maintain a really RESTful, clean API. So those are the 4 things that you would do there. The point here is, because some clients don't support all the methods, you can actually fake it out by putting the method up in the URL like you see here. And this is a common method that we use in the Ruby on Rails community, and I think it's exactly the right thing to do. It allows you to still maintain a RESTful approach to your API and work within the limitations of any specific client. Okay, now what about authentication? Okay, how do we handle authentication? There are a bunch of different ways to do this. Even internally at Apogee, my colleagues and I, we don't always agree about how to handle things like authentication and other stuff. But overall, here's my take. I think if we look at the top guys, PayPal, Facebook, and Twitter, in just these 3 services, you can see why it's such a pain to be an application developer building an app across different services, because they all handle things slightly differently. PayPal, they have a 3-legged permissions API, but it's proprietary stuff. And that's really no fault of their own. They had it in place long before OAuth was conceived. Facebook uses OAuth 2.0, and Twitter uses OAuth 1.0a. What should you do? I think you should use the latest and greatest OAuth, which right now is OAuth 2.0. The worst thing that I see is where people do something like OAuth, but different. And that just makes it feel weird and funky, and that can be really frustrating to an application developer trying to use it when he's got a perfectly usable OAuth library in his language of choice, but he can't use it with your stuff because you chose to do some variation for some reason. So I suggest folks use OAuth, and because a lot of this authentication stuff is going to be down in the header, it's going to also keep our URLs nice and clean, so developers can check it out and read it very easily. Now, I'm going to kind of clip through some of these other points at a rapid pace here. How do application developers use the API? So the first thing you should do when you're designing an API is every time you design an element, try to use it. Imagine how you would use that to construct a user interface or like an iPhone app or something like that. Because right away you're going to realize that some API designs end up being really chatty. And by that I mean just to build a simple user interface, you end up with dozens or hundreds of API calls back to the server in order to assemble everything together. So because of this, a lot of API designers will take a step back and say, you know what, forget all this RESTful stuff. I'm just going to build a 3 or 4 specific getter and setter, Java style methods that I need, and I'm not even going to worry about the RESTful thing. I think that's a mistake, but not a complete mistake. And here's what I think you ought to do. First, be complete and RESTful. Do it the right RESTful way and lay out what all of your resources are according to all the rules that we talked about today. And then once you've done that, then go ahead and provide shortcuts. Like if you know there's like, if 80% of all your apps are going to need like this sort of composite response, then go ahead and build a request that gives them that composite response. There's nothing wrong with that. But don't do that instead of being comprehensively RESTful first. So that's my suggestion on that. And importantly, the partial response syntax that we looked at earlier can help. It can actually, without having to create sort of any one-off base URLs, you can actually use partial responses to dig down into dependent resources where, like in our case, maybe the owner has an association with dogs, the dogs might have an association with veterinarians and so on. You can keep nesting these partial response syntax to get back just what you need to get back. Cool. All right. So now, oftentimes, this is sort of a corollary to the point that I just made. Oftentimes when you're building a UI, it seems like there's a bunch of domain knowledge that you need in order for the developer to create the UI that's right there. So here's the simplest example I can think of is if you look at this Twitter app, this is in some newsroom where some developer at a news company has created this really cool visualization. But you think just to get this tweet that is referencing this other Twitter user to be highlighted in that way, they had to parse the tweet coming back, color code it a different way, and display it in a certain way. So there was a lot of domain knowledge that was needed there. Now, you shouldn't necessarily change your API in order to make this easier, and this is where it's important to understand the distinction between an API versus an SDK or a code library. Don't overburden your API design by thinking about all these edge cases, because a lot of that is actually sitting closer to the client side, and you can push that burden over to the SDK while still keeping your API nice and clean. Okay, so there's a lot that I just talked about. You have to maintain all this stuff and iterate it too. That can be cumbersome. So what I usually suggest from an architectural perspective in terms of implementing these best practices is give yourself a buffer between the API interface on top and the actual implementation on the bottom. And here are a couple metaphors that might be interesting. One is like cartilage in a bone system or the middle gear in a gear chain. But for APIs, it ought to look something like this. Here's your application that's consuming the API. Allow yourself this virtualization layer. The whole point of the virtualization layer is you can make a nice clean design on top and then try it and then essentially turn it into an integration problem where you integrate that design on top of your key APIs. A lot of folks say they start writing their code and they try to build up from their business logic up to this really clean API interface. You don't have to do it that way. Give yourself this virtualization layer. So overall, we went through a bunch of content here. Be RESTful. You only need 2 base URLs. You shouldn't put verbs in those. Use your nouns and use plurals. You should choose concrete names over abstract. For JSON, you should follow JavaScript conventions, especially when it comes to naming your attributes. Use that question mark to keep the base URL simple. Swip all your complexity behind there. Borrow from the leading APIs. Account for exceptional clients. And then really add that virtualization in there. If you have questions, please throw them over there on the Google group. Myself or other members on the team or just the API community at large will get in there and have some good conversations. This is a lot of opinionated stuff, which makes it really fun. We're all not going to agree on all the approaches that we make, but I think the more we talk about this, the better we'll make the lives of application developers. Thanks for tuning in. Please subscribe to our channel on YouTube. Join that Google group about API craft. And if you want to contact me, you can follow me on Twitter on landlessness or just hit me on my email. Thanks a bunch, and tune in. We'll have another webinar in 2 weeks. Thanks, guys. Bye.